Scheiße!
So welcome guys to Sonic the Hedgehog, and welcome back to another teardown. And just a little apology for the beginning. I'm sorry for the acoustics, and sorry for basically I'm filming this in my garage because the thing I'm filming today is extremely heavy and big, and I just cannot move it up to my room no matter what I do. It's also pretty dirty, so you're gonna hear some ambient noise from the outside, cars running by, because I have to film this with my garage door open, since I don't know if with my studio lights I don't have any kind of proper way of actually lighting this whole scene up. But what I have for you today is something pretty special, and it's something you won't really get to tear down that often. It's something that you might not even get to see inside of. Like, it's something that's pretty special. So let me bring it in chop for you. It's a bit heavy. There it is. There we go. Is that in shot correctly? Yes, it is. Kinda, sorta. So this thing is a coffee vending machine. Yeah, it's the device that's responsible for making that god-awful coffee you drink in your office all the time. This is a Veromatic Vision, and ignore the brand here, no product placement. This thing, I got it off my local auction site for around 200 bucks. Let me actually try and move this, see if I can get a better aperture. There we go. It cost 4,000 Czech crowns, which equates to about $200, which is, I believe, quite good for something like this, because it's actually even good for the parts. Now, it was way more expensive than that because of shipping and all that stuff. Bought it off locally in my country, of course. So this thing is quite good. It should have quite a bunch of nice motors. It should have a pump in it, a heater block, and some valves, and possibly some nice control electronics, and a coin mechanism as well. So this thing, getting it shipped here over the Czech Republic, or basically the whole country, was a bit of a challenge, because this thing is 1 meter tall and it weighs 70 kilos. And I'm actually going to tell you the story how I ended up getting it here. So the price was kind of acceptable. I did end up paying the bar protection fee and all that, but the shipping for this behemoth was originally meant to cost 175 Czech crowns, which is around $5 or $6. It's rough equations. I'm going to put up a chart on the screen to just tell you how much that was. 175 crowns, or like $5 for shipping something like this, which is so big, heavy, and massive. It got me a bit on edge, so I researched and I looked on the site, and basically shipping via that site, they say that on the L size of the package, the longest side has to be to 1.5 meters, and the maximum weight has to be around 50 kilos. So I said, well, how can something like this, weigh more than 50 kilos? It's just got a heater in it, a bunch of valves and motors, and that's it. I was extremely wrong. Now, why I was wrong? Simple. There's absolutely no info about this on the internet. This is an enigma. This is a complete enigma. You cannot find anything about this. I drew a complete blank trying to find anything. I even asked on Reddit, and the only comment I got said basically, good luck. So I managed to get it. So it's a Veromatic Vision. Now, to the rest of the story. The shipment, I bought it, the seller received the money, and he contacted me saying, yes, I received the money, everything is all right, but we're sorry, but the courier couldn't ship it because it was too heavy. So I was, oh shit. So I was about to cancel the order, and the seller got back to me saying that if I pay like another 40 bucks, they can arrange like a pallet delivery for me. So I said, well, I was kind of grinding my teeth at this point because I was getting like out of my comfort zone. I was grinding my teeth a bit, and I never had any kind of experience with like pallet shipping or anything like that. So I just politely said yes, because 200 bucks for something like this, it's excellent price, and really wanted to see what's on the inside and maybe salvage some parts, because I'm an EE student right now, so I'm studying electronics, so parts like this will become handy for my graduate project and so on. So I managed to get it. So I managed to arrange the whole thing, but then the fun came. I managed to send the money to the wrong account. So I had to contact the auction site to return me the money, and then I had to send it to the right account. And after that hurdle was over, they fucking entered the wrong address, because it was originally meant to ship to mom's work so we could pick it up in the car, move it home. I had to rearrange the delivery to here because it just wouldn't fit in our car. And well, they changed the address and it arrived today, and well, it was quite a journey to get this thing home, but it's home now, so I guess that's a win. But there's one big also hurdle, because I wanted to put this thing on a trolley like this, but the base doesn't account for it. So this is literally unmovable for me. I cannot, for the love of God, pick it up. If you remember my last video about that Mitsubishi air conditioner, links are in all the usual places. That thing weighed 60 kilos and I couldn't even lift it up. This is even heavier than that. And that thing had 2 compressors in it. It's still in this same garage. So yeah, now this talking over, let's get and take a proper look at this. Okay, so just before I get into this video, some points I want to make. So it's the second day now. I was planning on filming the whole video yesterday, but I ended up going to the water park with my friends and, well, spent so much time out there that I didn't have enough time. It was dark outside, and as I said, my studio lights are not good enough for what I'm doing here, so I have to film with the garage door open. So, back to this. Updates from yesterday. I added casters onto this thing. I tapped holes in the bottom. There was like little support parts which was meant to be screwed to a base, which is where it was screwed into base. Well, I drilled and tapped bigger holes in there and put casters into it, so it's easy to move around. I ended up getting the cheapest casters I could because they were the only ones that would fit and that had a thread on them. Each one has a maximum load of 20 kilos, totaling in at around 80 kilos, the whole lot, so we'll just hope and cope that they don't fall apart. Now, getting this thing working is quite a bit of an issue because first, the power cable going in, standard single-phase European outlet. The power cable going in is a nightmare. It's a death trap. I'm going to show you later. The cable is ground through. It's almost bare conductors and it's been wrapped in electrical tape. Second thing, this doesn't have an internal water tank. It has to be connected to a water mains feed. And third of all, this thing. This is the coin mechanism for it. This is the coin acceptor. You would basically put the coins into this. It would decide what value the coin is, and if it doesn't accept them, it would reject them out. Well, I was trying to put this in here. I was stretching my brain where it goes. And I was thinking, what the fuck? So I actually remembered, I looked at the seller's listing and he was selling a second machine like this, and problem here being that this thing has a mounting position in it, but the connector that came with this, standard IDC ribbon cable, the connector in here, which is not matching for this, the connector that's for the coin mag, which was originally in here, is a completely different standard. So this is a bit strange, and I looked up the seller's listing, so there's nowhere to plug this in on the inside. I looked up the seller's listing, and he was selling a second one of these machines, although a smaller one from the same manufacturer, being a Veromatic, although a different one. Kafina, we'll talk about that later. But I looked that up, and it had this cable going to the coin mag in there, so unfortunately it looks as though the seller messed up the coin mechanisms, which is a bit of a hurdle. So me and the other person who bought the machine got the wrong. So me and the other person who bought the other machine, by the way, she was asking why I didn't buy the smaller machine. It was way more expensive because it was like fully functional. Yeah. So both of us ended up getting the wrong coin mag. Although it says bigger on here in translation, so it's for this bigger one. We'll try and figure this out in the course of the video when we go in depth into this thing. So other stuff. Why did I say that you that there's a very low chance that you'll actually get to tear down one of these things in your life? Sorry, neighbors just arrived at home. The reason being that you see this brand Kafina. Is it actually in shot correctly? Yes, it is. This brand right here, you see Kafina. That was a company which issued these things out on a lease. And, because these things back in the day, this is made in 2001, so it's 24 years old. These things were pretty pricey back then. Definitely. It would have cost like a couple $1,000s, these things. So, like $2,000 a pop, for the smaller machine back then, is what I would think. But, this company issued them out on a lease. And, yeah, you would just basically pay a monthly fee to use it, and the company would come out and service it. So they would, open it up and, screwdriver was sitting at the top. They would open it up, clean it out, replenish like the powder containers and refill the cups. Speaking of the powder containers, so I'm gonna break one fear here. If you think that this thing is a super automatic coffee machine, meaning it will if you think this is a bean to cup coffee machine, it's not. This doesn't use actual coffee beans. This doesn't grind up coffee beans, push them into a pot, percolate water through them, and coffee comes out. No. These things make something called instant coffee. And if you don't know what instant coffee is, well, let me just sum it up. Instant coffee is complete garbage. I don't know the people who drink it. It tastes awful. It sucks. It sucks. You know why it sucks? Because instant coffee is the lowest quality beans ground up, coffee brewed through them, and just freeze dried, and that turns into those granules you're used to seeing. So that's why I'm not a big fan of instant coffee. It just tastes like crap. And well, if you're in an office, this is the only option. I get it, but if I were you, I would just brew my own coffee at home and bring it in a thermos and just drink my own coffee, because this shit sucks. Now, if you thought that this thing's duties, everything in here is instant. Instant tea, that's the same story as with instant coffee, the lowest quality tea brewed and freeze-dried. Instant hot chocolate, which that makes sense. Most of us drink instant hot chocolate, and it's good if it's Starbucks. Even Cadbury's is good. Instant milk, that still makes sense. Yeah, powdered milk. But you know what's the most insane about this thing? It uses instant sugar. You know what instant sugar is? Surprise of surprises. Freeze-dried sugar water. Yeah, sugar dissolved in water and then freeze-dried. People drink this crap? Seriously, what a waste of technology to make coffee that's not even good. And if you think instant coffee tastes good, well, you have no idea what coffee's really meant to taste like. Yeah. So these things' duties, what it really has to do is heat water, pump it up into the correct place, and then just mix it up with the instant coffee and just send it out. And it, of course, dispenses a cup out for you, because actually, it's a fully automatic coffee machine. It gives you a cup. So yeah, that's about it. By the way, don't ask about this. Toshiba AC from the 90s. That's all I'm going to tell you about it. It's even heavier than this. So yeah, now all this briefing over, let's get into actually taking this apart and seeing what's on the inside. Okay, so this video was originally meant to come out like a month ago, but it's gonna come out like today, I hope so. It's 1 month even, is it? It's the 8th of October, because I had to delay because of school. Yes, I'm at an electronics engineering school, and here in the Europe, electronics engineering schools are way harder than in America. I don't know how it's in the UK and in the Asia, but in America, I've heard that you don't know shit when you finish doing the school, and I guess that's because you don't do physical stuff. We do physical stuff like soldering, connecting up stuff, making circuits. It's way more complex and way harder than in America and elsewhere, and I didn't have much time to film. Finally, I've got some time to finish filming this, so let's have a look at this machine. Front of it is pretty straightforward. You've got a coin slot. That's where you put in the money. You've got an LCD. That's used for displaying the user what's going on. You've got a control panel consisting of a lot of buttons. That's used to select what kind of drink you want and for customizing it and if you want a cup or not. Down the bottom here is your returned coins position. This is where it would return the coins. I don't know if this machine returns coins. If it just rejects coins because they are not. I don't know if this only rejects coins, if it actually does return. I don't know how this works, but this looks like this right here shows how much the drinks cost, so I don't know exactly how it works on here. Now over here is where it outputs your cup. So in here there is a cup dispenser, and it dispenses out the cups, and then there is a mechanism which moves in a bunch of output nozzles, and it basically pours it into the cup. Simple as that. So yeah, in here is a coin mech. I already spoke about the coin mech in the previous passage of this video, in the previous clip, that the coin mech that came with this is stupid because it doesn't fit anywhere and doesn't plug in anywhere. I don't know where it's meant to plug in because the connector that we'll find on the inside is completely different from the Molex ribbon. I don't know if it's a Molex ribbon connector, don't know, but from the ribbon connector that's on here, it is completely different from the connector you see on here. It's much bigger. It's more of like an automotive style connector. Well, back to this. How do you use this thing? Simple. As said by these instructions, direct translation. Pick your drink. So you can pick various things. You could have coffee, espresso, cappuccino, espresso with chocolate, and hot chocolate, of course. You can have tea or hot water. So you would select any one of these, and you would, for example, let's say you would want standard coffee. So you would push this button. Then after that, you would use these buttons over here, not these, I'll explain that later, to select how strong you want the coffee to be, how much sugar you want, and how much milk you want. Or if you want milk. I don't know how this machine would exactly be used. I think these buttons are just used to enable sugar or milk. I don't think you can select how much you want. But to select the strength, as you can see, you've got these two buttons right here to go up and down. So this would be, of course, weaker coffee. This would be stronger coffee. Over here, this would be either used to select milk or possibly just enable milk. And this would be used to enable the sugar. These three buttons over here are unused. So after that, after you have selected what kind of drink you want, and I guess it would charge you extra for the sugar and milk, you would then after you selected all that, it would display the cost of your drink on the display, and then after that, you would insert the coins into here if the fucking coin mech worked, and after that, you could select if you wanted it into your own mug, for example. You'd push this button, which is not how you'd spell no cup in Czech. It wouldn't be spelled like this. This is completely stupid. I don't know who done this, but I guess it's direct Google Translate. Or I don't know if Google Translate was around in 2001, which is when this was made. But anywho, if you want your own cup, you would push this. If you don't want your own cup, you want this to dispense out your disposable cup, you wouldn't push this. And then right after that, and then the last step, the fifth step would be, or in case, by the way, if you want to use your own mug, you would push this button. If you don't want it, you don't push it. And then right after that, after everything has been done, you push the start button and it will make the drink for you. So that's about how this works. You've got this flop down shelf right here. I guess that's for smaller cups, maybe. Don't know. It is, so you can flip it up though. It doesn't have a magnet on it though, so yeah, they could have added a magnet on it, but they didn't. I mean, this is not meant to be like a super niche machine. This is like not a niche machine. It's expensive. That's what it is. But it's definitely not anything I would call niche. It's just an industrial coffee maker. Anywho, this down here is the drip tray for overspill or just. It's a drip tray nonetheless. And if you think your drip tray on your coffee machine is fiddly enough, well, wait around for the drip tray that's in here because that's even more fiddly. So let's now have a look around the back. So I'm actually just going to walk to the back because I think it's going to be easier if I do it that way. So on the back, you've got the power input. This is one of the reasons why I will not be powering it on. The second one lies inside. Reefer madness. Yes, we'll look at that later. But look at the cable that's going into here. It's a single-phase European lead, so the plug, which is, of course, under the air conditioner. No, it's not. Get up here. Okay. The plug looks a little something like this. It is an EU plug, but this is a Czech EU plug. The standard EU plug, the Czech plug is different in the way, I don't know this about the Slovakian plug. It might be the same. I think only the Czech Republic has this plug, because the Czech plug has got a prong in the outlet, as evidenced by the outlet in this photovoltaic system distribution panel. This is where the ground goes. A standard EU plug has the ground contacts on the top and bottom. This plug is cross-compatible with any kind of outlet. A normal EU plug looks a little like this with the one for the Czech Republic. And exactly where the Czech Republic has a different plug than the standard EU plug. It might be some sort of local regulations or whatnot. I don't know the history of the Czech electrical codes, so don't know exactly about that, but hey, it's what it is. So this is the plug, and if you look right under this plug is severed. This thing has been moved around for quite a bit of time. It really does show. Look at the massive dent in the top of this. But this is a death trap. Like, it's got this electrical tape on it, which has rotten and decayed over the years. Plus, look at the state of the cable. Like, that brown wire, that's the live. That's where the 230 volts are. And that's almost worn through. That's almost the bare wire in there. So, yeah. That's not anything I'd fancy plugging in. And the first thing I would do before plugging this in is change out this cable, plus change some electrical components on the inside, especially capacitors. We'll get to the capacitors in charge later. Down here is your water inlet, standard kind of thing you'd find on a washing machine, standardized water inlet, essentially. It's got the gauze in there, it's got the filter. I don't know if you can pull it out easily. No, it doesn't come out easily, though.
By the way, focus unit, like iPhones, like after the new update, iPhone cameras don't work anymore. Come on. Anywho, back here, this grill is interesting because if you look in there, there's a little squirrel cage blower in there, a little radial fan, and that performs a pretty important function in the system, and we'll get to that later. So it's basically a little vacuum inside. We'll explain that later how that works. It's used for vacuuming up the excess instant drinks, of course, the excess dust, so it doesn't go on the inside into the electronics and whatsoever. Let's now get to this. By the way, these clip posts in here, I guess that's where the electronics are at the back. But now let's get into the main part, which we're here for. So to get into this, you have to have a key. Fortunately, I have one. So stick it in the side, turn it 90 degrees clockwise, and then it clips open and reveals the coffee factory. Yep, this is literally a coffee factory. Well, let's just get back to this. So let's move all this shit away. So what do we have in here? We got a bunch of functional blocks. First, in the door, we've got the position where the coin mech would have went, and as you can see, this doesn't really match up. This has got the coin slots, the reject slots, and the accept slots in weird places, and it just doesn't fit on here anywhere. There's definitely parts missing. I just want to fancy figuring this out. And it might be possible, as I said, the seller was selling in another machine. Or did I actually say it in that video? If I didn't say it again, the seller was selling a smaller second machine, and it's possible that he mixed up the coin mechanisms. Although it's got a label on it saying bigger, which would mean it would be for the bigger machine. Don't know. I have no idea. So in here, this box right here, that's going to be containing either the front panel electronics or the main control electronics. So that would make sense. We've got this thin ribbon cable, so it looks like this might be a processor and there might be a subsystem controller back in there. We'll have to see. We'll have to pop that open. Over here is a little counter which displays how many coffees it's made, and it's made 6,556 coffees. This thing's been really had some trouble done to it. It's a Veromatic Vision, and yeah, year of manufacture is 2001, so this thing's 24 years old or thereabouts. It's pretty old. So yeah, this is the connector for the coin mech, and as you can see why I cannot plug it in, you can see the difference. I think it's pretty obvious. I think there might be a second connector in here, but I don't know what this connector would be for else. I think it's for the coin mech. I think the seller might have mixed up the coin mech. Then again, this thing was so cheap, and the other machine was like only like 3,000 Czech crowns more expensive, like $100 more expensive. I mean, I wouldn't buy a professional coffee machine for that kind of money, you know? It just doesn't feel that safe. So yeah, over here, pretty interestingly done. They've got some EMI shielding on here. This is grounded. You can see the ground is brung to the front with these copper strips, and this ribbon cable runs to the back to the subsystem controller, or that's what I think it is. You've got another little piece of copper wire connecting the two parts together. They've really done a measure to ground this, which is nice. I mean, the age of this, I think there's going to be a high voltage CCFL backlight on the LCD, which would make sense. In here is the drip tray. You can remove that by undoing this, spinning these little tangs, and you can pull this out. Now let's remove this this drip grill. If you wonder what these white specks are, that's spider poop. That's spider shit. And the spider was pooping on this at some point. Yummy. And you wanna drink coffee out of this thing. That's gross. I think there are actually spiders in the powder containers. Oh, one moment, please. You just need to get that in there. Oh, God. Fuck it. There we go. Spin those tags into position. And it's back in place. That's about all the stuff you find in the front panel. Of course, pop this open as well to see what kind of electronics are in here. Most of the stuff lies in here, and first is the drip tray. So again, if you thought the drip tray in your coffee machine was fugly enough, check this out. Oh God, it's got mouse poop in it. Oh God, I have this in my garage. I'm an idiot. Look at this. That's got a couple liters of volume, that thing. So what else do we have in here? This over here is our cup dispenser. How this works is, you've got this carousel right here, which has got 5 columns, and each column or each stack, this whole carousel can hold 450 cups. Each stack holds 90. I don't know if this can hold different sizes. I think it could be programmed in here. But how this works is, the cups go in each one of these columns, and they sit in here. There are actually some left over in here. You can see right in there. How this works is the cups fall into this place right here, and there's an electromagnet, and there is some what you call it? I forgot what you call them. There's little stoppers in there, and there's an electromagnet somewhere in there which pulls on a cam, and that cam releases the cup, and it falls into this holder right here. So that's how that works. And once this whole stack is emptied, once special micro switches in here detect that the stack has been emptied, it's got another micro switch hidden down in there to detect the position of this. And once that's happened, it will turn and it will basically advance to the other stack, and that would refill, and it would keep doing this until the whole thing was emptied, and then it would of course show on the LCD that you have to add in more cups. This over here is the output, so you can see there's a total of 5 nozzles down there. That's where the 5 tubes connect. So it's gonna be hot water, tea, coffee, milk, and sugar, and of course hot chocolate. How this works is, there's this little box, and in here is a bunch of limit switches, and there is a bunch of limit switches. That's the one thing. And second thing, there is a small synchronous motor in here, which turns this cam, and this cam pulls on this tang, so it turns and brings this out into here. And once the coffee has been dispensed out, it will turn one more direction, and will push this back until it hits the limit switch, and it turns back to its original position. If you wonder where the limit switches are, it's these little rollers down in here. Focus, that's these 2 tiny rollers down here. So how this works is, it will dispense out one of the cups using the electromagnet. It will then turn this motor until it hits the limit switch, and that will bring out this little output thing, this little output arm. And it would dispense out the coffee or chocolate or tea or whatever the fuck you want. Once it's finished, this motor will turn again, and it will bring this arm back, and that's your coffee made. So then, what's behind there is where all the coffee is made. So if we turn, this can swing out like this, which is pretty neat. There's a magnet on here, and what we have in here, we've got these tubs, these containers. This contains all the instant ingredients. So what's the most funny part? The biggest one is for hot chocolate or cocoa or what you call it. And this is where each one of these tubs or containers holds the powdered or the instant ingredient or the coffee or whatever. And as I said, instant hot chocolate, instant coffee, instant tea, instant sugar, instant milk, it's just freeze-dried liquid ingredients. I don't know about the sugar. I think this might use granulate sugar. I know there is such a thing as instant sugar, but I don't know if it's allowed in the European Union anymore. So if you take one of these out, let's take the cocoa one out. So if we pull this out and open this, and this is where the hot chocolate resides in. There's this interesting spring mechanism, and there's this snail in here. And how this works is there is a motor with a gearbox back there. That turns through a coupling. That connects to this coupling, and that then turns this screw down here, and that slowly turns, and it picks up the powdered ingredient, and it then dispenses it out through the spout and into the mixer. We'll talk about the mixer later. And then in here, you can see it's this little cog, and that cog turns, or that gear turns this metal assembly with that spring, and that's just used to scoop the powder off the sides if it's stuck to the sides and force it down into the snail. This is how the bigger container works. I believe the smaller containers are a bit different. I'm gonna show you that later, but I need to get this back into here. It's fun doing this with one hand. Okay, let's see if we can actually get it to fit in. Okay, give me a moment. Okay, so I've pulled out some more of the containers. As you can see, the back there, this is where the motors connect. So, for example, the sugar one has just got this simple screw in there, and of course there's a coupling on the back, which is, as you can see, spins that screw, and that's what scoops out the sugar and then basically scoops it on and drops it out through the spout. The milk is different since we've got a gear, another cog, which is turned by the same, so again, coupling, turning, a screw, and that screw turns this gear. And as you can see, that gear has got springs in it, and this would mean that this is used for basically scooping the dust up and forcing more of it into the screw. And this is also done because it's for static sensitive powder, because static electricity makes the powder stick to the sides, to the walls of this container. And these springs are used to scoop it off and force it into the screw. And the same thing goes for the coffee. You can see the same design, except it's brown and it does stink. By the way, this is not what coffee is meant to smell like. It literally stinks. It's vile. Like, coffee smells really nice to me, but this just, it smells vile. As you can see, it's the same mechanism as the milk, except this one has got the coupling broken off. That's probably why this machine was so cheap. And the tea container is essentially the same story, because if we look into it, it's a bit different because we've got a metal spring instead of a screw. And again, it's the same thing, except it doesn't have the gear. So now, let's pull out all the rest of the containers, and give me a moment. I'm gonna put the lids back onto these, and then we'll have a look at all the electronics in here. But before that, let's have a look at the mixers. So these are your mixers, and this is where the instant ingredients get mixed. So how this works essentially is, the powder comes out of the spout, and it falls into this funnel. And then, as you can see, hot water is injected through this port right here, and it goes in there like a swirl to scoop out and dissolve any dust or powder that has stuck to the walls of the funnel. And then after that, after it's mixed, after it's all basically forced by the water, it falls through and into this cavity in here. And there's a little impeller in there. I'm not going to pull it off because this is essentially a nightmare to remove and put back on. And I want to keep this together because it's pretty neat so far. I wonder what's in here though. It looks pretty interesting. There's some adjustments. We'll have a look at that later. But there's a little impeller in here which spins and further mixes the water and the powder together. And after that's done, it comes out of this tube, and goes through here and into the output arm, which is what I call it. Now, if you noticed, there's these interesting CNC machined blocks. And as you can see, there's little connections. There's these little, like, knurled sort of top bits. And you can see it's connecting back there into a channel. And that's what the squirrel cage blower I talked about is for. What these do is, these are used to vacuum up, to suck up any excess dust that didn't dissolve. And that's done so it doesn't get into the electronics and, for example, doesn't gum up the motors or doesn't gum up any valves or doesn't cause any other trouble. So that's what's that for. It's just done to protect the machine. And by the way, that fan is what's responsible for making your office stink of terrible instant coffee. Yeah, that's the smell you smell around these coffee machines and these coffee vending machines. This is the blower responsible for it. Newer machines used a PC style fan, but I think this blower style is a bit more reliable, but I guess it's just been done to cheap out, I guess. Because this is more reliable. It's made by NVIDIA, which is a manufacturer which makes, for example, fans for convection ovens and stuff like this. German manufacturer. And that's so it basically sucks up the dust through these machined aluminum channels. No wonder this is so heavy. And it pulls it through this duct at the side, goes into the fan, and gets expelled out the back. That's the vacuum. So that's how this works. What's behind here? There's some pretty beefy. I've seen some teardown videos. There's a pretty beefy. I think there's some pretty beefy brushed motors in here used for spinning this. Used for spinning. There's gonna be some pretty beefy motors in there used for spinning the impellers. I'm not gonna take this off because it's gonna be quintessentially a nightmare to put back on. And there's also going to be some, it looks like shaded pole motors with gearboxes to turn the dispensing screws. Well, besides that, that's all we'll find in here. So, yeah. Now, let's get into the water stuff. So down here, we've got a boiler. This is where the hot water is made. And the boiler has got a bunch of things on it. It's got a bimetallic thermostat up there. It's got the two massive heater connections because this actually draws 2.5 kilowatts, 2,400 watts when it's heating the water. And there's also a little float. If you can see there, I may be able to operate it. I don't know, can I make it go? You can hear the switches clicking. That's a float in there used to detect if the water is depleted. Now, how this works is there's the water inlet manifold is over here, and it contains 2 solenoid valves, but only one output, and that suggests that it's got variable filling. So I guess when the boiler is empty, it will use this valve to fill it completely, and it will use this valve to refill it slightly when it's making the coffee. Over here, this kinked tube with this crimping tool on it, with this sort of crimping thing. This is the boiler drain, I reckon. And then also attached to the boiler is the water pump. And this water pump is responsible for pumping the water from the boiler and pumping it up into, I guess, some valves, which are then going to control where the water goes. Because the outputs on here are hot chocolate, coffee/sugar. This is just hot water. This is going to be coffee, and this is going to be tea. So there's going to be, I guess, 5 valves in here used for controlling where it flows out, and this pump is what pumps the water from the boiler. And interestingly, if you see, the pump can only pull out this pump can only pull out water up to this level. So the pump can only use this much water, and the rest water just sits stale in there. And you know what? That's pretty gross. You know, stale water sitting in a heater is definitely not a hygienic thing, but it's done for a reason, and that's that, you know, heating water, like when this would deplete it's very uneconomical to deplete the whole tank and then refill it again and just heat a massive quantity of water. It's more economical if it just uses up a little bit of the water and then, of course, refills it and has to heat just a little bit of water and doesn't have to heat up a massive chunk of, it just basically ends up heating warm water instead of a massive chunk of cold water. And it's actually more hygienic than I thought because it would be using the valves. This red tube right here is what actually outputs the water into the boiler. And it would be, of course, once this will be connected up to the mains feed, it will activate probably both valves to fill it up completely. It would heat up the water, and then when we're making the coffee, this pump would be running. And it will use up the water to about this level. Once it reaches that level, now that float is going to be what's detecting when the water level is too low. When that float will fall too low, it will trigger some switches that will in turn trigger one of these valves to fill it at half the speed, and it will fill it up to the top again, and it will be basically depleting it to this level. And then, of course, when the boiler will be drained and it will be refilling it again, it will, of course, use both valves to refill it again. So yeah, this is the pump on it. Now, the other problem, why I'm not going to be turning it on, you see these capacitors? Yep, good old refus. There is quite a lot of them in here. There's going to be way more in here, I reckon, than that. And I don't want to stink out my garage with this. And it looks like a proper nightmare to replace them because they're connected in crimp connectors. And this thing's really not worth fixing anyways. So yeah, so that's the pump. Interestingly, there's this tube coming out of the top of the boiler. And it's got a bimetallic thermostat on it, bimetallic thermal cutout. And this looks to be an overflow because there's no physical position in how the wires are designed. It looks like it's not meant to connect anywhere. So I guess when the boiler overfills, this will go through and and the hot water will possibly trigger this until the circuitry of the boiler has overflowed. Or it might be when it starts boiling the water and it starts like overspilling, the water starts spilling out of it. This is used to detect that and will maybe cut off the heater. Don't know how that exactly works, but yeah. We've got another tube back here coming from the top, and it connects next to the pump, and that's going to be like a water return, I guess, from some sort of manifold, hydraulic manifold that's going to be in here. And, well, other things we got in here, we got a relay, and looking at how the relay is connected, that's going to be a relay for the pump. Yeah, that's going to be a pump relay. That's all we'll see in here. There's one big, massive, chunky connector back there that's for the heater. And that's all. There's something disconnected right here, but there's just 2 pins running here and some ground connections unused. So I guess it might have been some sort of, I don't know what it could have been. A light? Don't know. And looking down in there seems to be a toroidal transformer, a large toroidal transformer behind in here, which is going to be the power supply. Yeah, if I stick my hand in there, I can feel a toroidal transformer. I'm not going to take this off because it looks like the proper nightmare to remove, and as said, I'm not going to try and destroy this. That's about all the stuff we'll see in here. So now it's time to start exploring all the electronic bits. So I'm going to get the screwdriver and I'm going to put you on the tripod and we're going to see what's in here and what's in there. Okay, so let's first have a look into the main panel right here, into the control panel electronics. So I'm going to try and get around the tripod to dismantle this. Okay, just flops them like that. Okay, here we go. Some properly old electronics. Okay, so I'm gonna move the tripod slightly more down. That's better. Okay, let's adjust it a bit. There we go. So what do we have in here? We've got a bunch of stuff. We've got one large control PCB on here. Now, I thought this would be just a processor, but looking at this, we've got not one but two microcontrollers. This is a microprocessor, and it's an EEPROM over here, so we microcontroller. So it looks like this controls everything, and it looks like the cable running off to the back, there's just gonna be, I don't know, some relay. There's gonna be some relays behind there. And so I guess some of the valves and some of the power electronics, but this is the main brain box. This is what controls everything. Up here, we've got a high voltage power supply, and that's going to be used for powering a CCFL backlight on the display. And I first thought it was going to be a VFD, but if you look at the trimmers on here, this one's actually used for adjusting the contrast, which did give away it's an LCD up there. And in that case, this is a CCFL backlight driver. Other stuff we have in here, we've got the coffee counter, as I call it. And if we pull it out, I'll bring you a bit closer. If we pull it out, simple as that, it's just a standard electromagnetic counter, so it's just an electromagnet being energized to advance a counter. About the other stuff in here, we've got a bunch of connectors. This large wiring loom is going up to the LCD. This ribbon cable back there is going to the control panel, to the keypad. And this cable over here is going to the service keypad, and the service keypad, the service keypad is this over here. So you've got a bunch of buttons, so you can select. So these 4 buttons, so 7, 8, 9, and 4, as you can see, according to this chart, are used to activate water into either one of the 4 mixers. The 5, I don't know what that does, no idea what that is. The 6 is used to activate the water pump. 1 is used to either disable powder or disable water. 2 is used to advance the cup holder, and 3 is used to drop the cup. Hashtag is used to display the amount of coffees made. Star does nothing, and 0 simulates a coin being inserted. No touchy. I guess that's because of static electricity. So now let's have a closer look at the control electronics in charge of the whole machine. Try and make this, yep, there we go, that's good. So this is where all the stuff happens. Over here is a Philips PM80C microprocessor that controls the whole system. It's the main brain box, it does everything. Over here we've got a crystal for it. Then there is some serious stuff. We've got a Snaphat lithium battery timekeeper. This is the real-time clock, and that's going to be depleted right now, so that will be the first thing I would go to replace. That's the first thing I would replace. Up here is an EEPROM, and it's, Veromatic Vision is what that stands for. So this is going to be what holds the software. Over here, we've got a very interesting, I thought this was some sort of thermal block at first, but it's actually a dip switch, so maybe for activating service settings or something like that. Over here, we've got another microcontroller, and I guess that's going to be a subsystem controller, I guess. We've got a crystal for that as well. Looks like another EEPROM down there. So it might be a microprocessor. Up here are some adjustments for the LCD, so brightness and contrast. And some other standard logic arrays and stuff like this. This is just some logic interface. This is some I/O to all the rest of this stuff. There's some other I/O stuff over here, like banks of resistors and capacitors for, I guess, some protection. Up here are some inductors and all of that stuff, some power regulators and all that circuitry. I'm going to take this very briefly, not anything in depth, because we've got a lot to cover. And what we're really here for is not really the electronics. We're here for the actual theory of operation of this machine. Over here, this little connector is where the coffee counter connects. Up here is where the LCD connects. This is where the main keypad connects. And this is where the CCFL driver connects. And that's all you'll get to see on here. There's some other stuff like an opto isolator down here. And this looks into be the interface for the CoinMex. So that's the opto isolator for that, for some added protection. And there's just support circuitry like some logic chips, just some logic stuff, Schmidt triggers and whatnot. And the LCD is going to have its own driver. I'm not going to go too in-depth into that because it's just not worth doing. And this looks like the proper kind of nightmare to disassemble. So that's all we'll find in here. So that's all that's in the in this cubicle over here. So now it's time to look into the second cubicle behind the powder containers and see what we have behind there and what makes the whole thing tick. Okay, so now filming with the flash because it's cold outside. I don't have the proper studio lights. And of course, I'm not gonna be filming with the garage door open. So now let's see what's behind here now. Interestingly, over here, if I zoom in and tilt the camera enough for that, or the phone, or my iPhone, shall I say, over here is some adjustments. And these, looking at them, are either pressure adjustments or volume adjustments. I think there are volume adjustments. Now, there could be two ways that they're doing this. Either these are trimmers and it's got a flow meter, and it's got some flow meters in there, and it's measuring the precise flow out to the mixers. Although in that case, that's really not, that doesn't make any sense, because those adjustments in there look nothing like some standard trimmers. They look like some variable inductors from the 1960s. And really, this machine is just too early for that kind of shit, having multiple flow meters to measure multiple flows. And just this is too complex for such an early machine like this. So presumably, this is either some pressure regulators or flow regulators. I'm gonna say some flow regulators. Yeah, it's gonna be possibly some flow regulators, and there's just gonna be some solenoid valves activating the flow. And those flow regulators are going to be, and those solenoid valves are going to be time controlled. There's going to be precise timing in here which is going to correspond to the flow. And the adjusting points are going to be flow regulators. It could be gravity valves like you find in vending machines, which is what this is, which is a valve with a little hose, with a little vent hose, and it's a volumetric valve. You know, it's a standard solenoid valve, but with these flow regulators built into it. And depending on how long the valve is on, that much water flows out. And these adjustments is what's used to adjust how much water flows out over a selected period of time. Anywho, all that rambling over, it's time to pop this open. Interestingly, up here's a little tamper switch used to detect if the cover is shut. If the front cover is shut. But now, other stuff down here are the couplings, the motors for the powder containers. But with all that rambling aside, oh, okay, all right. Now we're talking. Oh my God. This is really neat. This is really super neat. I really like this. This is about one of the most beautiful things I ever taken apart. Look at it, it's so beautiful. Everything is organized, everything has got its own space. All the wires are nicely loomed. All the tubes are nicely going everywhere. It's just, all the tubes are nicely oriented. It's built so nicely. Everything's so nicely linear. There's no weird angles. Everything is just, it's got its own, it's got its own rules to it, and it just looks so neat. But anywho, all the bragging about, let's have a look at what we got in here. So, we've got a bunch of functional blocks. Up here is some sort of high power is our power supply, and that's a second transformer. So we've got a Teardown transformer hidden down in there. And then we've got a second smaller transformer up here doing something else. Over here we've got a hydraulic manifold, and that's what I thought these were. These are gravity valves, these are volumetric valves. And the adjustments we saw is flow regulators. We'll have a look into that later. Then over here is a control cubicle, and we've got a metric ton of Omron relays. That's a nice score. And down here are just some connectors, and it looks like that unit can be removed. Yeah, it looks like this whole electrical unit can be removed as a whole, so you can replace it entirely, because you wouldn't really do much repairs on it. But back then, repairs, component level repairs and stuff like this were still normal. But anyways, this is about all the stuff you'll see in here. And do you wonder what all this gross stuff? Wait, what is that? Is that construction foam or something? Oh, it's crusty. Let's taste it. Oh God, it's sugar. That's sugar. Wait, how the fuck did sugar get up there? Like, I would expect it, it's also down in there. I would expect it to be in all the wiring looms and stuff, because that's where the sugar container is. But how in the world did it get up there? Like, did someone tip this thing over when it was running or something like that? Well, I guess if someone tipped it over when it was running and flowed water, all this stuff would be corroded and we wouldn't have any kind of working electronics in here. So I don't know how in the world that sugar got up there, but, well, anywho, there's sugar up there and it tastes good. It tastes like caramel. Hope I won't get a disease from this. Oh God. But yeah, anywho, let's have a look at all the stuff we have. So the first position we'll have a look into is this cubicle right here. This is the main power supply cubicle. So behind here, I'm gonna try and hold that cable up. There we go. Let's try and pull it up. In there is a power filter module, so that's gonna be a capacitor and an inductor. Over here, that's filtering it's an EMI filter, basically. Over here, we've got a power transformer used for powering the electronics in here. And this big thing right here is either a massive relay or a contactor, more of a relay. And that's going to be used for activating the heater. And again, we got a refill capacitor across that. So that's our heater relay. Then, right over there, right under it, we've got our hydraulic manifold. And how that works is pretty straightforward. We've got 5 solenoid valves. And how this works is, as far as I know, water comes in, according to the arrows, water comes in over here. And I'm actually going to try and zoom out to make it look better. There we go. Water comes in over here. And it gets distributed over the 5 valves. And each valve dispenses water to each position. So this would be the hot chocolate. This would be milk and sugar. This would be hot water. This would be coffee. And this would be tea. And how this works, and then we've got a return hose, we've got a return tube down here, and that, of course, is the return we saw right next to the pump. Then, how this works is, when it's dispensing the coffee out, it'll open the corresponding valve corresponding to the mixer which it wants to use. And these adjustments you see down here, these are flow regulators. And as I said, the time the valve is open is proportional to the amount of water that comes out. Simple physics knowledge. But how this exactly works is, because we got no flow meter in here, how it works is, that flow regulator, these bits down here, is what adjusts the flow coming out of the valve. So, shall we say if this is completely tightened, the valve will only output like 10 milliliters per 1 minute. If this is fully open, it will output 100 milliliters per minute. And this is what used to determine, because how this works is, this thing has a precise timing to the precise amount of coffee that comes out. So you can basically use this to vary how much coffee you want this thing to make. And that's, I think, pretty smart, because you don't need any kind of software adjustments for this. So if you're, for example, a greedy operator, you might set this lower to output less coffee. And if you're a more forgiving operator, you would set this way higher, and it would output more coffee for the same time. You know, simple. The time the valve is open equals the amount of water that's dispensed out, and this screw changes how much water is dispensed out over a set period of time. As simple as that. But now let's get into the electronic side of things. So I'm going to try and pump the tripod up a bit. Yep, let's just go get up. Yep, there we go. So over here is where all the magic is. This is what controls literally every single part of the machine. So we've got, so I've counted this. There is around 22 relays in here. Plus, it looks like there's 22 relays in here, I think. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's going to be 22 relays. It makes sense. Yeah, it is 22 relays. 23rd relay over here, and 24th relay down in there. So 24 relays in total in this machine. So these boards are what control all the power loads. So each board has got some logic circuitry on it, pretty simple. Some logic gates, Schmidt triggers, flip-flops, as simple as that. Each board has got a set amount of relays, and each board is going to be controlling, I guess, each part of the machine. So some of the relays are going to be controlling the valve, some are going to be controlling the motors, some are going to be controlling the pump and the water inlet valves, and some of them are going to be controlling the main fan. They're going to be controlling the dispenser, the cup dispenser, so the electromagnet in it, the synchronous motor. It's going to be controlling the output arm with its own synchronous motor. It's going to be controlling the 5 dispenser motors. It's going to be controlling the 4 mixer motors, the pump motor, which has actually got its own relay, the 2 inlet solenoid valves, the blower motor, and of course the 2 water inlet solenoid valves. And possibly, because this is super overkill, one of these relays is going to be used to control that main heater relay as well. Basically a Darlington configuration but relays instead of transistors. Now, if you look closer onto these boards, you can see that the transformer connects onto here. And I don't see any kind of rectifiers on here. Oh, no, there is a rectifier. So the power goes in. There is a full bridge rectifier down there. Sorry, Electro Boom. There is two, what looks to be, yeah, that's going to be smoothing capacitors and a voltage regulator. And there's some other stuff. You've got some fuses over here. Those are just going to be power supply fuses, I reckon. And then you've got some standard TTL logic and relays. I don't know what those are. What are they? I think they are maybe opto-isolators or... I know what they could be. For the heck could I know what they could be? I think there might be miniature relays, or most likely just some high-power opto-couplers. Some power resistors down here, and that's it. The other board is pretty similar to that. Power goes in, small bridge rectifier, smoothing capacitor. And you've got, again, TTL logic and some relays. And if you look, which is pretty nice, each relay has got its own indicator LED to show its state if it's on and off. So these LEDs will tell you if the relays are on and off. That's pretty smart. So what I think is this for? This transformer over here is going to be for the electronics, I reckon, and the bigger toroidal one is, I think, going to be for the relays. That makes sense. The valves are 230 volts, and if you look at the valves, they've also got reefer capacitors across them for filtering, so there's literally a reefer capacitor across every single electromagnetic component here, including valves, motors, etc. So that's all that controls this thing, and like, this is the most neat thing about it. I really like this compartment. So yeah, that's all that is to this. So now it's time for the last bit. We'll have a look into the cup dispenser. And okay, so now it's time to take a look inside the cup dispenser. And before we do that, I'm gonna stick the lids back onto the powder containers. So the first thing we would do to take it apart is remove the carousel. So remove the top, remove this plastic. I'm gonna pull it up just slightly and remove this little tang. Pop that out. It should now just pull straight out, which it does. There we go. This is the lid, if you're wondering, just a standard plastic lid. So what do we have on here? We've got, if we look closely at this, we've got a shaft, which is used for turning the carousel. And interestingly, this is, no wonder it's so heavy. This white metal plate, that's cast metal. Yep, that's either cast, that's gonna be cast metal. Yep, that's cast metal. Cast iron, that's surprising, or cast aluminum. And here are the cups. This is the kind of cups it uses, standard disposable cups. So this is where the cups go. This shaft in the middle here turns the carousel, and this right here, as you can hear, is a micro switch used for detecting the position of the carousel. Then down in here are two more micro switches used for detecting the position of the cup. So one of them is going to be detecting the position of the cup, and the other is going to be detecting if there's a cup present, I reckon. And I think one of them is going to detect if the cup has fallen out, and the other one is going to detect if the if cups are present. There's two of them on there anyways. And that's all you can see in the top. Now let's have a closer look at the bottom of the carousel. So the bottom of the carousel has got the shaft mounted in it, and it's got these little pegs which ride up against this lever right here, which actually is the micro switch, and that's what the system uses to tell at which position the carousel is. It's very, very, you know, overbuilt, this thing. You know, it's back then, it's from back then when stuff was made properly. Anywho, let's take a peek into this. So, and it does. And there we go. And this is the underside. Yep, exactly what I thought. So, how this works is, we've got a large electromagnet on here, which pulls on a cam. It's got a spring on there. And do you see these little cams in here? Gonna zoom up on that. You see when I pull the electromagnet, these move out of the way, and that's what drops the cup. So when it wants to dispense the cup, it will activate this electromagnet, and that will turn these cams, and that will drop the cup. I'm gonna remove this rogue cup which has just fallen out. You can see we've got two. Actually, zoom up for that. We've got two micro switches on here, which is what's used to detect the position of the cups in the dropping mechanism. And we've got one more micro switch up there used to detect the position of the carousel. Over here's the electromagnet, and down here you can see there's a tiny geared synchronous motor and another reefer capacitor. Oh my god, there's a lot of them in here. Down here is the little geared synchronous motor, which I spoke about previously. That's what's used for moving the carousel around. It's as simple as that. That's about all the stuff you'll find in this card. We've got a terminal block right here. That's what holds the reefer capacitor, and that's about it. So nice cast metal assembly. So that's it. That's all you'll find in the cup assembly. So I'll stick this back together, and I'll actually stick the rest of the machine back together, and we'll have a look at the motor, which is used for driving out the output arm. Okay, so now it's time to take a look inside the motor for actuating and moving this output arm. So it's very difficult to remove. There's cables and stuff in the way, but I'll try my best to show you what's in there. I'm gonna try and show you. So get this off. There's let me take the phone off the tripod to make it easier. So you've got another reefer capacitor in here. That's not interesting. But you can see there's another geared synchronous motor in there, and that's what drives the cam down here. As you can see, there's two more limit switches. They're back there. You can maybe just see them. That's about it. So again, geared synchronous motor driving this cam in and out. So not much to see in here. So I'll put this whole thing back together. I'll close it all up and move it away, and we'll get to the reverse engineering. Okay, so 3 painstaking hours of reverse engineering the whole vending machine. Here it is. I've got both the schematics for the electrics and for the fluidics, meaning all the electrical stuff and then all the stuff that handles the water. Now, one disclaimer, I didn't go as in-depth as reverse engineering the circuitry itself. The schematic you see on the screen right here is the electrics, and I've done my best to reverse engineer. There might have been stuff that I've forgotten. I might have forgotten some stuff. It's pretty simplified. It's very, very simplified. That's why some of the stuff has only got like one connection going to it. Is just to keep it simple. Because this machine, like, it contains 250,000 motors, a lot of different stuff, and it's just very hard to reverse engineer. So here are the electrics. So some main points. Over here is the main controller PCB. That's the PCB we saw in the front panel. Next, you've got the interface PCB number 1, which is the PCB in the other compartment behind the power containers, the one on the left. And you've got the interface PCB number 2, and that's the one on the right. It's those two boards with a lot of relays on them. Over here is our power input circuitry. Over here is our user interface. Over here is the limit switches. And over here is all the motors, valves, and the heater. So let's start over with our user interface. So if we zoom in right here, by the way, the program I'm using, it's called ProfiCAD. It's the name right here. The license, I believe, it's a full license costs like over 8,000 Czech crowns. It's like over $200. It's like $200, $300, or $400 or thereabouts. It's a pretty expensive program, but it's great because it handles electronics, it handles distribution, it handles high voltage distribution networks, hydraulics, pneumatics, even industrial processing, stuff like this. But right here, right here is our main controller PCB. That's the thing we see inside the front panel, the big black box with the control electronics in it, and that handles mostly the low voltage interface stuff. So one of the things it handles is the point mechanism. That's what basically just counts how much money you put into it and if it can dispense the drink out for you. This over here is our portion indicator. That was that counter we saw in there, that electromagnetic counter that shows how many portions it has actually outputted. Then this part over here is the main display at the front. And then we got 2 keypads. The first one is the user keypad. That's the one you'll find on the front of the machine, which is where you select your drink and if you want your cup or not, or how strong you want the coffee, if you want milk or sugar, yada yada yada. And then over here is the service keypad. That's the small numeric keypad we've seen on the inside of the machine, and that's used to activate the systems inside to test them. Then right here are the limit switches. So the index, CPOS, and CP limit switches are used for the cup dispenser. The index one is the limit switch we is the limit switch that's on the top, and that's what detects at what position the carousel with the stacks of the cups is. It's basically the one with the rectangle on the top. The CPOS is the cup position, and that's one of the limit switches in the cup chute in the cup output, and that's used to detect if there's a cup and with which position the cup is. Then the CP, that's called cup presence, and that's used to detect if there even is a cup in there. And TMP is the tamper switch we saw, which detects if the door is open or not. And you've got limit 1 and limit 2, and those are the switches which are in the motor, which drives the output arm in and out, and this is the 2 limit switches we saw on there. So that's all the low voltage stuff you see over here. So that's all that stuff. So let's have a look at our power input. So the power input is right here. So socket comes in, live and neutral go into the EMI filter, and the ground connects to the filter valve that goes to the ground. All the components that are grounded, I didn't bother drawing the grounds because it would be just too much. So then right after that goes into the interface PCBs, and that distributes the power to the relays. And this, you got the system and power transformers. The system transformer is the toroidal dual transformer hidden inside the machine that I didn't show you. That's used to power the electronics. And you've got the power transformer. That's the one we saw, the one with the single winding. That's the one we saw in the control electronics cubicle, in the cubicle where the interface PCBs are. And that powers all the relays and basically all the DC stuff. All the DC stuff that is basically that isn't the electronics, the mechatronics, shall I say. Then we've got the big boiler relay over here, and that switches the boiler through a bimetallic or for a capillary thermostat, and the boiler is right over here. Tied to the boiler, we've got 2 thermal cutouts. One of them is the overheat, that's hidden on the top of the boiler. I forgot to show you that one. And then we've got the overflow, and the overflow is located on that overflow tube we've seen on the output of the heater. It's in the drip tray. So that's the thermal cutouts. So next, let's have a look over here. So the interface PCB1 controls the electromagnet, which is labeled drop, which is responsible for dropping the cup. Interface PCB1, I mixed them up. The right, so the interface PCB1 handles all the motors, and it controls this fan, which sucks up all the excess powder. And it controls then motors 2 to 6, labeled RT1 to 5. That's ratio. They are called ratio motors because they and those are the motors which turn the screws in those powder containers to output the powder. Then it also controls motors 7 to 10, which are labeled MX1 to 4, and those are the mixer motors. Those are the motors responsible for driving the mixers. Then we've got motors 11 and 12. They're called labeled CA and OA. CA is cup advance, and that's the little geared synchronous motor we saw, which turns the carousel with the cups, the stacks of the cups. And then OA is output arm, and that's the motor which flings out the output arm when it's meant to output the drinks. Note that the ratio motors are geared shader pull induction motors, and mixer motors are just straight universal motors. And the motors 11 and 12 are synchronous motors, and motor 13 is another induction motor, and that's a pump, and that's the pump. That's the main water pump we saw. So that's all the motors. And then we've got 7 solenoid valves down here. Those are handled by interface PCB2. So interface PCB2 handles all the 7 valves. So valves EV1 to 5 are the valves in the hydraulic manifold. They're basically the volumetric valves we see in the top of the machine. And they're labeled corresponding to what they do. So CC is chocolate. So that's for the chocolate. So that's for the chocolate mixer. EV2 is SM. That's for the sugar and milk mixer. EV3 HW. That's for the hot water output. EV4 CF is the coffee. For the coffee mixer, and EV5 is for the tea mixer. Next, we've got EV6 and 7, and those valves are the inlet valves. That's the inlet manifold. So input 1 and input 2. Now, those valves are pretty interesting because they are flow restricting valves, and if you open only one of them, if you open both of them, the water flows into the boiler. These fill valves, basically, the water flows, if both of them are open, the water flows into the boiler at the full flow. If only one is open, the boiler is filled only at half flow. You know, it's when the boiler has to be filled completely, both of them activate, and the boiler has to be just filled partially when the water is depleted. It will just activate one of those valves. I don't know exactly how it works, but yeah. We already talked about the boiler. So that's about it in here. That's all you'll find in here. So, main controller PCB, the PCB in the mainframe panel, it handles the coin mechanism, the portion counter, the display, the user keypad, the service keypad. And then it handles the 6 limit switches, so it handles the index switch, the cup position and cup presence switch, the tamper switch, and the 2 limit switches on the output arm. Interface PCB 1 handles the drop electromagnet and all the 13 motors. And interface PCB 2 handles the boiler as well as all the 7 valves. And of course we got the mains input, EMI filter, and the 2 power transformers. So that's it for the electrics. So now, let's get over to the hydraulics, or shall I say fluidics. Okay, so now the fluidics portion of the thing, and the fluidics is what handles all the water in the machine. So let's explain some of the stuff. So the boiler over here, I'll explain what everything does. So this sort of zigzag wire in here, that's the heater, and this arrow pointing down with this line, that's the water level sensor. That's the float we see. So, our water comes in, and we've got inlet valves 1 and 2. These are what control the filling flow for the heater. So when the heater is completely empty, as it is now, both of the valves would open to fill it at full speed. When only a part of the water is depleted due to the design of it, when the flow detects that only a part of the water is depleted, because the machine knows it already filled the boiler completely, it'll activate solenoid valve 1 to fill it at only half speed. And I know the float has got 2 positions, but I won't get too deep into that. And yeah, and as I said, I forgot to draw in the stuff into the electrics. I forgot to draw in the float switch. Doesn't matter now. So, then, those of course go into the heater. The heater's got a drain valve, and I know the drain valve is pretty rudimentary. It's just a crimped silicone tube. That goes down into the drip tray down here. So yeah, now the water comes in through the top, and it can go 2 ways. If it overfills, or starts boiling or something and the water starts spraying out, it'll go through this tube down through here and over the spill thermostat, which is the weird thermostat we've seen on the tube to tell the system that hot water is overflowing, and that goes down to the drip tray. But normally, it would fill and heat the water, and when the pump would start up, the pump would pull the water through here, would go through the pump, then the pump would output the water into the 5 main solenoid valves. Now we've also got a return right here back into the heater, because that's designed so if none of the valves are open, the water can flow through. It's a safety feature. So this is basically a closed loop, so if all of the valves are closed and the pump starts up, the water will just flow backwards and forwards through the system until the pump shuts down. It's just a safety feature so that it doesn't overpressurize. So the water is distributed from the pump into 5 solenoid valves. The first valve, labeled choc, that's chocolate, and goes into the chocolate mixer. And then the chocolate mixer is where the instant hot chocolate is mixed with the hot water, and it comes out. And it comes out of the mixer and through the output arm. Solenoid valve 2, labeled SM, which means sugar and milk. That goes into the sugar and milk mixer, which is where the sugar and milk are mixed. And then after that, of course, mixed with the hot water, and then of course output it into your cup. Valve 3, labeled hot water, is obviously used. Labeled HW, hot water is obviously used to put extra hot water into your cup. Then valve 4, labeled CFE, that's coffee. That goes into the coffee mixer, which is where the instant coffee is mixed with hot water, and that goes into your cup. And then you've got the last valve, valve 5, the tea valve, which goes into the tea mixer, which is where the instant tea is mixed with hot water, and then it comes out into a cup. And that's as simple as it is. Like, when you look at the machine, like, its task is pretty simple, right? It's just meant to make hot water with freeze-dried stuff. And if you take it apart, it might seem extremely complex with all those wires running around and motors and switches and valves and tubes everywhere. But if you really draw it out, the electrics are the most complex part. The actual fluidics, it might seem complex at first, but it just has to perform a bunch of tasks. It has to fill the boiler to multiple levels, fill it at multiple speeds, and it has to, just output the water to 5 mixers. That's all it really has to do. So that's about it for the reverse engineering. So now, let's get to the end. So now basically, this is it for the whole video. This is all I have for you today. So yeah, so that's it for the reverse engineering. Okay, so that's it for this video, guys. That's all I have for you today. I'm sorry I didn't go sorry I didn't take apart the mixers and have a look at the mixer motors and the dispensing motors, the ratio motors as they're called, because it would be just way too much of a nightmare, and it's kind of dark outside already, so it's a bit too much for today. So anyways, thank you for watching, and yeah, so hope you liked it, hope you learned something new, and tell me in the comments what you think, and as always, thanks for watching, and I'll see you guys in the next one. Bye.